this is Mrs. Hibbler. Good morning. And I am here to review with you your constant motion lab. I want to talk to you about how you can set it up. Okay, so let's start out and let's look at this gentleman right here. This gentleman here, he could be at any position on this path right here. Okay. And so I'm going to just change this here to this, and I'm going to hit play here. When you're watching this man, what do you notice about his motion? What can you say about his motion? Okay, and then I'm going to pause it, and I'm going to clear it, and I'm going to put him back all the way over there. Reset everything. And then let's put him back. And I'm going to say, I'm going to try the same thing here, but I'm going to now change this value. What can you say about this gentleman's motion this time? Is it the same as it was before? So how would you distinguish between the first time he was walking and the second time he was walking? What was different about those two sets of motion? Well, today, I want you to think about the first time that you saw the gentleman walking. So we're going to clear everything, reset it. The first time you saw him walking, what did you think? Say it out loud so the whole class can hear you. What was that motion like? What questions do you have about that type of motion? Could you ask a question like, how does the time that somebody moves affect the position with that type of motion? Could you write a hypothesis around that? Possibly, maybe. If I let time pass, what will happen with the position of that man? If I let time pass, what will happen with the position of that man? If time increases, will his position also change towards the positive direction? If time increases, will his position change in the positive direction? What's the relationship then between time and position? So you can go to this website here. You just go to phet.colorado.edu and you look for the moving man simulation. Okay, so let's look at this again. This time I am going to reset everything. And right now, we're trying to keep it simple. We just want to look at this movement of the man again. And we have time here on the bottom, and we have position here on the top. And then we want to see what these graphs look like. So right now he's at time 0. Let's see if I move him. I can move him from one position, and I can move him to any other position. Okay. Let's see what happens when I hit play and I start recording the values. Right now he's not moving, but what happens if I start changing his position as time goes on? And what happens if I go really fast? So I wasn't able to keep my hand really steady, but if we made this like a line of best fit, what would you be able to say about that line? What would the slope of this line tell you? What is the relationship between time and position? Slope would be rise over run. So if I said it was like 4 over 12, that was the slope. 4 over 12. What would that tell you? Okay. And I could actually put him back. I can clear this. I can put him back here at this position. And I can hit play. And I could change these numbers here. I can make him jump. Let's see here. -3. And maybe I'll say 5. And maybe 7. And then back to -8. Oops, I took too long. But what does this graph show you? When we have a position versus time graph, when the line is flat, what does that tell us? What kind of motion are we seeing with the person? When I change the position, he literally jumped from one position to another. Now, unless this is like a standing long jump, we typically can't do that, but it's a computer, so I did it. And then what was happening when the line was flat again? And then we jumped. Actually, let's see if we can go back and play it again. Let's see if it will let us go back. I don't know if it will let us go back and play it again. Oh, playback. I got to hit playback. So we can actually look at the playback. Okay, we see here in the beginning, he's not moving. And then he jumps to another position. And then he's not moving. And then he jumps to another position, but he's not moving. And he jumps to another position and he's not moving. And then he jumps to another position and then he's not moving. So when we have a position versus time graph and we have the line is flat, what's happening with the motion of the person? When the line goes up, is the person moving forward? Or are they moving backward? When the line goes down, is the person moving forward? Are they moving backward? These are all great things to think about. And then, like, let me reset this again. Clear, reset all, yes. And oops, I didn't want to reset everything. I'm going to move this gentleman back down here at position -10. I'm going to hit play. And I'm going to try to keep him moving fairly steady. Does this look like a constant motion to you? I'm doing the best that I can here. It's kind of hard. Okay, we'll stop right there. Okay. So now, once again, we have a position versus time graph. I'm going to play back. What do you notice? He's not moving. Now, what do you notice about the motion of the gentleman? So when we have a position versus time graph, what does the graph, that slope of the line, tell us? Okay, and then I'll just show you one more thing. I'll record again, I'll clear it, and then I'll reset everything. And I'll try to, one more time, have this person move. I'm going to hit play. Okay, now the line looks really different this time. I wasn't able to keep my hand like super steady. But how is this different from what we saw before? Like where it's curving up like this, just from 0 to 4. What will we say about that motion? Let's play it back. I don't know if this will look great or not. What can we say about how did his motion look different? So what I'd like you guys to do is you write a question about motion, about constant motion. You should be able to write a hypothesis about constant motion. Just to set this up in practice and understand the experimental design and the scientific method, for the beginning, let's start with position and time. Okay, this is the x-axis, time, and this is position, this is the y-axis. We're just going to do that to see if we can all talk about what this line means. And then what can you do with the line? If it's a straight line, can you calculate the slope? If it's not a straight line, well, maybe we'll look at that a little bit later. If it's not a straight line, what does it tell you? And then you'll notice that there are some other terms here, and you can actually look at those and you can start thinking about how they relate to the graph that we're getting. But let's just start out with the position and time and make sure we're on the same page with that. Can you do this lab on your own in class and collect data? That's another question I have for you. So can you have someone in class walk at a particular speed? And then can you collect data on position and time? Can you graph that data? And then can you say what the slope of the line is and what it represents? How the line represents the person's motion? Can you interpret through a graph what's happening with the person's motion? Does the data support your hypothesis or not? And then what did you learn from the graph? And then we can try to look at different kinds of motion. Maybe then after that, we can either using this particular website or using a ball rolling down an incline, we can start to look at other kinds of motion. You also can use the motion sensors. See if you do this lab with a person walking at a constant speed versus you do the lab and you're taking hand measurements versus you do the lab with a motion detector, will you get the same results? I don't know if you have any remote control cars that can move at a constant speed, but definitely if you don't have cars, you can just have people walk. Okay, let's see how that works out, and let's see what type of data we get, and let's see what you guys think about that. And then if you can answer those questions, because I really want you to try to relate this back to your Rube Goldberg. If you can answer those questions, then think about things that will be happening in your Rube Goldberg machine. Are things going to be moving at a constant speed? Will things be moving down an inclined plane? And if so, how will that affect your machine? Do you want things to be moving at a constant in a constant motion, or do you want the motion to be changing? Do you want consistency in your Rube Goldberg machine? So just think about that. Okay, if you can set this up today, collect a little bit of data, graph it, and then practice writing a conclusion and a discussion, that would be great. And then after that, if you can practice doing the same thing with the motion detectors, I think that will really reinforce what we're trying to learn. And then you can practice the homework and see if you can answer the homework questions on the walking man. And then we'll be able the next day to go into the building and asking questions and designing our Rube Goldberg machine to try to solve our problem of creating something really cool to celebrate the Chinese New Year. So I'm looking forward to seeing what you guys come up with, and I hope I'll talk to you soon. Bye.